This LOS is describe how cash flows of fixed income securities are structured. Structure of a bond's cash flows. So here we're going to look at principal repayment structures, and there's three examples here given. Bullet, fully amortized, and partially amortized bonds. So the bullet bond we also going to call plain vanilla, and that's the bond that we should all be familiar with. And you can see in this example the principal value is 1,000 and it's 6%, and you can see that it's an annual payment bond. So the investor cash flows, 1,000 goes out at the beginning times 0. You receive $60 per year in terms of interest, and you receive your principal back at the end of 5 years. So you can see the interest payments are always the same, $60, and the principal payment is done once at the when the bond matures. Okay. The second case is the fully amortized bond, and this is like an annuity, or this is like paying back a loan. Okay. And you can see to do that, we're just going to use the financial calculator. We're going to put it into the N mode. The periods per year is 1 because it's annual payments. N equals 5. Interest rate is 6. Present value is 1,000 plus minus key because it's negative. Future value is 0. And so when we compute the payment, we get 237.39. So you can see the payment in this case is the same amount every year. So what happens then, this becomes a loan amortization table. You can see, number one, the interest in the first year is always the same. It's $60, no matter what the method. But in this case here, you have an investor cash flow of 237. If you subtract the interest, that's going to give you your principal repayment. And your interest at 6% is going to be based on the principal value at the end of the year. So the next year, you've got the same payment, the 237.39, minus the interest equals the principal repayment, and that's going to give you your principal at the beginning of the year. That's the beginning of the year minus the payment. Principal payment gives you the principal at the end of the year. Okay, so that's just a loan amortization. We should be familiar with that. Should not be too difficult. And so a bullet bond, is a plain vanilla. A fully amortized bond is like an annuity. And then finally, we have the partially amortized bond, which is fairly similar to the amortized bond, except that in this case, we have 1, 2, 3, 4 payments are the same, but it ends with a higher last payment. Okay, so the amortization is a little bit different. So a partially amortized bond is like an annuity or a loan repayment, but it has one higher last payment. So we'll do a quick practice question. The structure that requires the largest repayment of principal at maturity is that of A, bullet bond, B, fully amortized bond, or C, partially amortized bond. Okay, that question shouldn't be too difficult. A is correct. The entire repayment of principal occurs at maturity for a bullet or plain vanilla bond, whereas it occurs over time for a fully and partially amortized bonds. Thus, the largest repayment of principal at maturity is that of a bullet bond. And we can see that here in terms of the principal repayment. We have the 1,000 at maturity. That's the largest. The bullet bond, which we called the plain vanilla. Okay? And you can see here with a fully amortized bond that it was like a loan. We were paying back principal over time because we had the same investor cash flows. And finally, with the fully amortized bond, the principal payment again was varied over time with a larger principal payment at the end, but the largest principal payment is with regards to a bullet bond, a plain vanilla bond. Structure of a bond's cash flows. Principal repayment structures. Sinking fund arrangements. A sinking fund arrangement is another approach that can be used to achieve the same goal of periodically retiring the bond's principal outstanding. The term sinking fund refers to an issuer's plans to set aside funds over time to retire the bond. The benefit of a sinking fund arrangement is that it ensures that a formal plan is in place for retiring the debt. For an investor, a sinking fund arrangement reduces the risk the issuer will default when the principal is due, thereby reducing the credit risk of the bond issue. But investors experience potential disadvantages with sinking fund arrangements. First, investors faced reinvestment risk, the risk associated with having to reinvest cash flows at an interest rate that may be lower than the current yield to maturity. A quick practice question to check our understanding. If a bond's issuer is required to retire a specified portion of the issue each year, the bond most likely A is callable, B is a step-up note, or C has a sinking fund provision. Okay, that question should be so easy because we're just looking at the sinking fund. And C is correct because a sinking fund provision requires retirement of a portion of the bond issue each year rather than retirement of the entire issue at maturity. Continuing with structure of a bond's cash flows, now we're going to look at coupon payment structures. So you can see there's quite a few different methods here, and this is meant to just have a brief description of each. So the first one is the floating rate notes. Floating rate notes do not have a fixed coupon. Instead, their coupon rate is linked to an external reference rate such as LIBOR. So this is all about the coupon payments. So the coupon payments can change. They're not fixed. They're going to float, and they're going to follow a reference rate such as LIBOR. What is a step-on coupon bond? The coupon of a step-up coupon bond, which may be fixed or floating, increases by specified margins at specified dates. So it's stepping up. The interest is stepping up. Credit-linked coupon bonds. A credit-linked coupon bond has a coupon that changes when the bond's credit rating changes. So if the credit rating goes down, you could imagine that the coupon payment would go up. If the credit rating goes up, the coupon payment would go down. Payment in kind coupon bonds. A payment in kind, PIK coupon bond, typically allows the issuer to pay interest in the form of additional amounts of the bond issue rather than as a cash payment. Deferred coupon bonds. A deferred coupon bond, sometimes called a split coupon bond, pays no coupons for its first few years, but then pays a higher coupon than it otherwise normally would for the remainder of its life. And finally, index-linked bonds. An index-linked bond has its coupon payments and/or principal repayment linked to a specified index. Inflation-linked bonds are also an example of index-linked bonds. Governments are large issuers of inflation-linked bonds, also called linkers. Quick practice question. Investors who believe that interest rates will rise most likely prefer to invest in A, inverse floaters, B, fixed rate bonds, or C, floating rate notes. C is correct. Investors who believe that interest rates will rise most likely prefer to invest in floating rate notes. In contrast to fixed rate bonds that decline in value in a rising interest rate environment, floating rate notes are less affected when interest rates increase because their coupon rates vary with market interest rates and are reset at regular short-term intervals. Consequently, FRNs are favored by investors who believe that interest rates will rise. A is incorrect because an inverse floater bond is a bond whose coupon rate has an inverse relationship to the reference rate. So when the interest rate rises, the coupon rate on an inverse floater decreases. Thus, inverse floaters are favored by investors who believe that interest rates will decline, not rise. B is incorrect because fixed rate bonds decline in value in a rising interest rate environment. Consequently, investors who expect interest rates to rise will likely avoid investing in fixed rate bonds. So 2 more practice questions to finish this LOS. The first one, investors seeking some general protection against a poor economy are most likely to select A, deferred coupon bond, B, credit-linked coupon bond, or C, payment in kind coupon bond. And one last practice question to finish this LOS. The benefit to the issuer of a deferred coupon bond is most likely related to A, tax management, B, cash flow management, or C, original issue discount price. Okay, I think that's a fairly easy question to end on. The benefit to the issuer of a deferred coupon bond, you're paying your coupons later, it's related to cash flow management. B is correct. Deferred coupon bonds pay no coupon for their first few years, but then pay higher coupons than they otherwise normally would for the remainder of their life. Deferred coupon bonds are common in project financing when the assets being developed may not generate any income during the development phase, thus not providing cash flows to make the interest payments. A deferred coupon bond allows the issuer to delay interest payments until the project is completed and the cash flows generated by the assets can be used to service the debt. And that's the last slide for this LOS. Thank you.